Web-based user authentication. How in the world do we make somebody prove who they are if the computer or the device they're using does not support a supplicant to do 802.1x? The answer, my friend, is web authentication. Let's begin. I'd like you to think back in your mind regarding the last time that you logged on or connected to some wireless network that was quote-unquote free or included. Maybe it was at a hotel, maybe it was at a coffee shop. What exactly was it that you needed to connect? Well, we need to know the SSID, and hopefully it wasn't a rogue SSID, a rogue access point, but one that was put there by the establishment. We need a signal, meaning the radio frequency. We'd have to be able to see that and have a strong enough signal to work with it. And then we also might or might not need some credentials. It depends on how they set it up. For example, maybe they gave us the SSID and they gave us the quote-unquote password. And anybody who has the key is able to go ahead and associate with the access point. They don't have to use that same key for encryption. In fact, many of the times that we're using free Wi-Fi, the actual signals that we're sending back and forth between our computer and the access point are not encrypted. That's why it's a really great idea if you're using any type of free or hotel-provided Wi-Fi that once you connect, if you're going to use it, make sure you build a VPN tunnel all the way through that, from your computer to some other headquarter location or to your home, wherever you have a VPN termination point, so you can make sure you encrypt all the data as it leaves your computer. So let's take the hotel as an example. So we check in and we want to use the hotel Wi-Fi. We know what the SSID is because they told us, or it says Hilton or whatever it does. And so we connect, and then the first time that we try to use a web page, it intercepts our web page and it asks us for some information. They might ask us, for example, what is your last name and room number? Or they may just have a page that comes up that says you need to agree to the acceptable use policy for this Wi-Fi. In any case, how do they pull that off? What's the magic behind the scenes that they could use to do that type of open authentication than intercepting your first web page? And one way of doing that is using a process called Web Authentication. It also could be very important if you have wireless users that their computers don't have the software to be a supplicant. See, in 802.1x, we need to have the supplicant, the software that can feed the credentials over to the authenticator, and then the authenticator talks to the backend server. But if somebody's doing this, they BYOD, which is bring your own device, which at a hotel, all the customers are bringing their own devices. Who knows what we're going to have as clients? We could have Macs and Linux and Windows and handheld devices from all different kinds of vendors. And we can't really guarantee that each one of those is going to have the appropriate supplicant to work with a 802.1x infrastructure. So here's the game plan. Without using 802.1x, and we still want to authenticate the user, here's how we do it with the web. So we have Bob, and Bob has a computer, and Bob associates with an SSID. And what we do is we do open authentication. So you're at a hotel, there's no authentication whatsoever, you're associated with that access point. And what's allowed through is DHCP works, because we're going to need that for an IP address. And also DNS works. Bob's all happy, he's got an IP address, he's got DNS capabilities. So when he sends his first traffic out of his browser, so he's going to surf the web, he opens up his browser, goes to his homepage. When that request goes through, it's actually going through the access point, which is using CapWap back to the controller. And what's going to happen is that controller, who would normally forward that packet onto the default gateway with the HTTP request, the controller is now intercepting. And it says, wait a second, I don't know who you are yet. So instead of giving them the page the customer is going to, it redirects them to the virtual address. On the controller, if we set up the virtual IP address of 1.1.1.1, they get an HTTP redirect message to that IP address. So now the client, unbeknownst to him in the background, now is going to 1.1.1.1, which the controller sees as himself, and he pops up his page that says, hey, I'd like you to authenticate. What's your username and password? Now that pop-up page doesn't have to just say what's your username and password. We can customize it. We can send it to an external authentication server. There's several options there, but that's how the interception happens. And then once the user has been authenticated, or at least done what we want them to do on that page, we can then forward them off to the real internet. Now, originally, they may have been going to CNN.com or some other website like that. And what we can do after the authentication, we can send them to www.hotel.com or whatever website we want to send them to. So the big picture is user associates. First time they send web traffic, it intercepts that. They authenticate. Once they've authenticated, we redirect them to whatever website we want to. Maybe it's advertising, marketing, etc. And then now that they've been authenticated, the rest of their traffic, like CNN.com or whoever, can go free and clear. So now Bob's on the internet and he's happy as a clam. Now for the authentication, we have several options. One, we can use the internal database on that wireless LAN controller if we want to. We can use an external radius server if we wanted to. So the wireless LAN controller would simply ask the radius server, hey, is this username and password correct? And there's yet another option. We could send it off to a lightweight directory access protocol server. So maybe the hotel, as people check in, they're automatically populating a server as a centralized way of clearing all the authentication. So that way the wireless LAN controller doesn't have to be updated every time somebody checks in or checks out. It can simply refer to the LDAP server as far as a yes or no regarding a username and password. So the user experience, all they need is the SSID. They really don't need too much else. They associate, they get an IP address via DHCP. DNS works for them, but once they go with HTTP, they're intercepted and they have to authenticate. So what do we need to set this up? Well, if we're telling the controller to do it locally, we need local users on the controller. If we're telling the controller to use a radius server, we have to define that radius server. Or if we're telling the controller to use an LDAP server, we have to define that LDAP server, meaning we need to tell this wireless controller how to log in and make the request of that system. We'd also probably create a brand new wireless local area network. And for the security, for layer 2 security, we're going to probably say none, which equates to open authentication. And at layer 3, we're going to say we want to do web authentication. And then for the web authentication, we can be very specific on how we want to authenticate the user. Local database, radius server, or LDAP. So we're sitting at Virtual Wireless Controller 1. Let's go ahead and set up the backend infrastructure for the web authentication. The first thing we're going to do, if we're going to use an LDAP server or a radius server, we'd want to define those servers. So under security, if we want to set up AAA servers, we go to authentication. There's our radius server that we set up previously. If we want to take a look at the details of that server, we can simply open it up. And this was connecting over to the ICE, the Identity Services Engine, using radius to connect over to it. If we wanted to set up an LDAP server, we go back to security. On the left-hand side, select LDAP, Lightweight Directory Access Protocol, and we'd simply add one. Now I have one here as an example. Let's go ahead and look at the details of it. So here's the IP address of our LDAP server, and there's the default port. Now one of the problems is, let's say you have this LDAP server, and it's got all these usernames and so forth, and their passwords stored in it. Is anybody just allowed to go knock on the door and say, hey, is this a valid username and password? The answer is no. We need to tell the wireless LAN controller about a user and password combination that can make the requests. So that's what this is about right here. On the authenticated simple bind, we're going to specify which username should the wireless LAN controller use when it makes the requests. Now that also implies that on this LDAP server, this user account called AD Access User, or whatever you called it, exists on this system and has the ability to do the queries and asking the question regarding the validity of usernames and passwords. So these guys right here in blue would be where you put the password for this username, the one who's going to be making the requests. So if you have 1,000 logins a day, that's 1,000 times that this user will be going over to the LDAP database and asking the question, what about this guy? What about that guy? Now in LDAP, there's a structured order to the database. So for example, it might look something like this. At the very top, we might have COM, and we might have CBT nuggets. And then below that, a container called users, another container called computers. And this organizational structure also applies to other directories like Active Directory in Microsoft. So when this user logs in to make these queries, where should it search inside of the organization? And so we need to tell it, where do you want to start searching? And this says, go ahead and start at the users container, which is in CBT nuggets, which is in COM, which is this area right here. The next thing it wants to know is, what is the user attribute? And in the case of a Microsoft environment, the value would be SAM account name. And it's very likely that if you've got Active Directory or LDAP servers, you're probably going to have somebody in your organization that's also intimately familiar with the attributes for that specific LDAP implementation. The user object type is a person. The default timeout is 2 seconds. If that's acceptable, you can leave that. And the default server status is enabled. Unless you had some reason to turn that off, you'd want to leave that on so it would work as well. And now once we save this information, we can use that if we want to for one of our sources for validating a username password combination. So I didn't make any changes here, but if I had, I would simply click on apply, or if I created a brand new LDAP server, I'd click on apply. And also from time to time, we want to go up here and save configuration as well, just to make sure that if the controller reboots, it'll come up the way we left it as far as the configuration is concerned. So we've got a AAA radius server. We've got an LDAP server defined. So our next step is to create a brand new wireless local area network. Tell it from a security perspective that we want to do web authentication, and then furthermore specify for that web authentication what type of system do we want to use, the local database on the controller, a radius server, or an LDAP server. So this right here just represents a boatload of fun that we've been having as we've gone through and we've added more and more. For this one, to add a brand new wireless local area network, we simply go up to the create new, click on go, we'll give it a name, and we'll also use an SSID called WebAuth. We'll click on apply, and that gives us the opportunity to now put in the specifics. So we want to enable this, yes. And for this demonstration, I'm going to go ahead and stay up in the 11A range. So I'm staying clear of all the noise down at 2.4 gigahertz. And I'm going to put them on to VLAN 30. So we could absolutely use VLAN 30 again, or we could go up to interfaces on the controller, create another virtual interface, another dynamic interface, associate it with a different VLAN, and use that as well. I know that VLAN 30 has a DHCP server present. There's also a default gateway. All those details are already in line, and that's why I'm just reusing that. By default, it's saying I want to do WPA2 and 802.1x, and that's usually great. However, the exception here is that what we are going to do for WebAuth, we are going to say for layer 2 security, we are going to use none. Now, does this imply that all the traffic between the user and the access point is not going to be encrypted? And the answer is yes, that's exactly what it means. All we're doing with WebAuth is we're authenticating who that user is before we let them go and surf the web. So we're not doing any encryption at layer 2. But however, at layer 3, we are going to make a change. So for layer 3 security, we're going to say, I want to do web policy. And this says, warning, what's going to happen is we're going to allow DHCP traffic and we're going to allow DNS traffic. And the reason it's allowing DNS is because if we don't, the customer, if he never is able to resolve a name to an IP address, the client is very likely never going to make that HTTP request out to the internet, which is the one we're going to intercept at the controller. And our next stop is AAA servers. So let's say, for example, just to start off, that we're going to do local authentication. We're not going to use AAA servers, so we'll remove this checkbox. And we're not using LDAP servers, so we're not going to specify any servers here. But if we scroll down, this specifically says for web authentication, how do you want to authenticate the users? Now, for testing purposes, I don't really like leaving multiple choices for the authentication because I want to control it. In a production environment, you might have one method first, and then if that's not reachable, like a radius server can't be reached, then fall back to a separate method. But if we know we want to use the local database, you can take these guys off the list. So for web authentication, we're going to go ahead and use the local database. Now, it also implies that we'd have at least one user in that local database, which we've done previously and is under the security tab under local network users. We created the user Bob. So with that in place, let's click on apply, and we should have a brand new wireless network now live and ready to go. And through the magic of Insider, let's go ahead and take a look. And there's our WebAuth right there. So it's just as a verification that it's up and active. Now if we go back to monitor, and currently we have no clients. So if we get out a client, for example, I'm going to go ahead and use an iPhone again, and we select WebAuth, the DHCP works, the DNS works, and then the client, as soon as the client tries to forward traffic, HTTP, it's going to be redirected to the virtual IP address of the controller, which if we go to controller and look at the interfaces, here's our virtual IP address right here, 1.1.1.1. The client is redirected there and prompted for their username and password. Now that experience for the user, what they see, we can control that by going to security, and down here under web authentication, we can actually tweak and play with the web login page. So we can use the default one that came with the controller, or we can actually download a template from Cisco and tweak it the way we want it so they see that when they connect, or we can send them to an external authentication server. So the default is internal, and after they've successfully authenticated, we can spin them off to, for example, www.cbtnuggets.com once they've authenticated. Now, if that website is not their original website they were going to, they'll get over it. They'll simply go to their website again, and the second time they go, it'll go nice and successfully because they're now authenticated. So let's go back to monitor and take a look at our clients. This is my one client who's connected to the WebAuth network. If we want to see the details of that client, we'll go to clients and we can take a look at the details of that client. So let's say we want to use a different server. We don't want to use the local database on the controller. We want to move to Radius or LDAP. That is so simple to do. We go back to the wireless local area network in question. We go to edit the details of it, in this case, WebAuth. We go to security. And on the AAA servers, what we're going to say is this. We want to go ahead and use, for example, a Radius server. So we specify the Radius server here. We scroll down and say, you know what? I want to use Radius. And we either put it at the top of the list or make it the only choice. So maybe we use Radius first, and then we have a fallback of the local database if our Radius server is not reachable. If we want to use LDAP, we just simply remove this server from the list. In fact, I'm going to say AAA servers, no. I want to use an LDAP server. It'll give us one from the list that we created earlier. And then scroll down here and say, I want to use LDAP as my primary method for web user authentication. So we'll put them at the top of the list, move them up. And if we wanted to, we could remove the others or have local as a backup. And then make sure we click on apply so we can save those changes. Another thing that I want to make you aware of is that let's say that you and I log in to test something. So we're out on the floor, we have a laptop, we log into the wireless, and then we want to try to make some changes right from our wireless device. By default, anybody coming in over an access point, over the wireless, who's trying to also manage the controller says, I don't think that's a good idea because you could totally do something that would disconnect you from that network. And as a result, it doesn't let you do that by default. However, if we go up to management and we say, you know what? I want to be able to go ahead and manage over a wireless connection. We simply go to management via wireless, and click this checkbox right here. So the default behavior is that if you're connected over wireless through an access point that's managed and controlled by the controller you want to work with, it won't let you. In this video, we've identified that it doesn't require 802.1x to authenticate a user. By turning off layer 2 security and doing basically open authentication, we can do layer 3 authentication of users using web authentication. I hope this has been informative for you, and I'd like to thank you for viewing.